Hello learners, welcome back to the new session. I am Rajat Tiwari, lecturer, University Teaching Department, CSV2. In today's session, we are moving forward to the topic of compass surveying, which will be including computation of included angles, adjustment of compass and errors. This session is tailored to deepen your understanding of compass surveying techniques and to help you identify and correct common errors. We will explore each element thoroughly, ensuring you are well equipped to handle practical surveying challenges with precision. In this session, we will be discussing the following points, which include the calculation of included angles from bearings, calculation of bearings from included angles, different adjustment of the compass survey, and sources of error in compass surveying. Now, let's discuss what is included angles. In compass surveying, an included angle is the angle between two consecutive lines of the survey measured at a survey station or point. So, what is the importance of this included angle? Accurately measuring included angle is crucial for calculating directions and for the successful plotting of survey data. Included angle may either be interior or exterior. In surveying, included angle is defined as the angle measurement in clockwise direction from preceding line to the forward line. The included angle between two lines may either be interior or exterior angles as previously said, but when traversing is done in anti-clockwise, the included angles are interior, whereas in case of clockwise traverse, these are exterior ones. They are always measured clockwise from preceding line to the forward line. As you can see from this figure 1, in which the traverse run anti-clockwise from A to B, then C, D, E and then to A. In this, the included angles will be the interior ones. In the next figure 2, in which traverse run clockwise from A, B, C, D, E and to A. The traverse is running clockwise, hence the included angles will be exterior ones. Now, we will learn how to calculate the included angles if the bearings are given to us. So, knowing the bearings of two adjacent lines, their included angle may easily be calculated as, firstly we will take case 1 in which we have been given whole circle bearing of two lines. As you can see from the figure, in a clockwise closed traverse A, B, C and A, AB is the forward line and CA is the previous line at station A. Let WCB of the line AB is alpha and whole circle bearing of line AC is beta. Therefore, the included angle BAC, as you can see from the figure, can be calculated by it is equal to forebearing of the forward line minus back bearing of the previous line. The forebearing of the forward line is alpha and the back bearing of the previous line, that is CA, is beta. As you can see, it will give, from the figure you can see, it will give you the negative value. But in the process of calculating the included angle, if the value is negative as stated, we have to add 360 degree to get the actual included angle, which will be the exterior included angle, as this traverse run clockwise in this case. Now, if there is a case in which traversing is done in anti-clockwise direction in the same figure, say from A to C, B and then to A, then AC will be your forward line and BA is the previous line. So, the included angle CAB will be equal to forebearing of the forward line minus back bearing of the previous line. So, forebearing of the forward line is beta and back bearing of the previous line is alpha, and you can see from the figure it will give you a positive value, and it is the interior included angle as the traverse is running anti-clockwise in this case. Now, we will be taking case 2 in which we have been given the quadrantial bearing of lines. So, firstly we will take, if the bearings have been measured to the same side of common meridian, the included angle alpha can be calculated as theta 2 minus theta 1, referring to the figure, that is the difference of the bearings. This is true for all the quadrants. Secondly, referring to the figure, if the bearings have been measured to the opposite side of the common meridian, as you can see it, the included angle alpha can easily be calculated as alpha is equal to theta 1 plus theta 2. It is easily can be seen from the figure, that is, it is the sum of the bearings. Thirdly, if the bearings have been measured to the same side of different meridians, the included angle can be given as alpha is equal to 180 degree minus theta 1 plus theta 2, that is the difference of 180 degree and the sum of the bearings. Since in this case it is given that it has been measured to the same side of different meridian, the line AB has been referred from the north meridian and line AC has been referred from the south meridian, and the included angle have been given as 180 degree minus theta 1 plus theta 2. In the fourth, if the bearings have been measured to the opposite side of the different meridian, the included angle alpha is equal to 180 degree minus theta 2 minus theta 1, that is the difference of 180 degree and the difference of bearings. With help of this, we can calculate the included angles. Now, we have to calculate the bearings if included angles have been given. So, knowing the bearings of a line and included angles between successive lines, the bearing of remaining lines can be calculated. How? Let the observed bearing of line AB be theta 1 as given. Alpha, beta, gamma, delta, phi, etc. are the included angles measured clockwise between adjacent lines, as you can see from the figure. Theta 2, theta 3, theta 4, theta 5, etc. are the bearings of successive lines which we have to calculate. So, how we can calculate it? It is easy. The bearing of BC theta 2 can easily be calculated as theta 2 is equal to theta 1 plus alpha minus 180 degree. You can easily go with the geometry and calculate it. Similarly, the bearing of CD can easily be calculated as theta 3 is equal to theta 2 plus beta minus 180 degree. Next, the bearing of DE, that is theta 4 is equal to theta 3 plus gamma minus 180 degree. The bearing of EF is theta 5 is equal to theta 4 plus delta minus 180 degree. And last, the bearing of FG, that is theta 6, can be calculated is equal to theta 5 plus phi minus 180 degree. Referring to the figure, it is evident that each of theta 1 plus alpha, comma, theta 2 plus beta and theta 3 plus gamma is more than 180 degree, and theta 4 plus delta is less than 180 degree, and theta 6 plus phi is greater than 540 degree. So, hence in order to calculate the bearing of next line, the following statement can be made. What is that statement? We have to add the included angle measured clockwise to the bearing of the previous line, and if the sum is more than 180 degree, we will deduct 180 degree from it, and if it is more than 540 degree, we will deduct 540 degree from it, and if it is less than 180 degree, then we will add 180 degree to the bearing of the next line. Now, let us take some examples to understand deeply. In the first example, it has been given to determine the value of included angles in a closed compass traverse A, B, C, D and A conducted in clockwise direction. Given the following 4 bearings of the respective lines. These 4 bearings have been given of line AB, BC, CD and DA respectively as 40 degree, 70, 210 degree, 218 degree. Firstly, we will make a traverse of this question. Then, as you know, the traversing is done in clockwise direction. So, the included angle will be the exterior angles. So, included angle is given as it is equal to forebearing of next line minus back bearing of the previous line as we discussed earlier. So, the included angle A is equal to forebearing of AB minus back bearing of DA, that is equal to 40 degree, that is forebearing of AB minus, since forebearing of DA is given as 280 degree, we can easily calculate back bearing of DA equal to 280 degree minus 180 degree, which will equal to, equation will be equal to 40 degree minus 280 degree minus 180 degree. It will give you minus 60 degree. Since it is negative value, so we will add 360 degree to it. Then it will be equal to minus 60 plus 360 degree. It will result in 300 degree. So, included angle will be A will be 300 degree. The included angle B can be calculated as forebearing of BC minus back bearing of AB. Forebearing of BC is given as 70 degree and back bearing of AB we have to calculate. How we can calculate? As forebearing of AB is given as 40 degree, we will add 180 degree to it and we can calculate back bearing of AB. So, equation will be 70 degree minus 40 degree plus 180 degree, which will give you minus 150 degree. Then since it is negative, we will add 360 degree to it, minus 150 degree plus 360 degree, which will result in 210 degree. So, included angle B will be 210 degree will be your answer. Next, included angle C will be calculated as forebearing of CD minus back bearing of BC. Since forebearing of CD is given as 210 degree and we can calculate easily, forebearing of BC is given as 70 degree, we can calculate easily back bearing of BC as 70 degree plus 180 degree. So, equation will be 210 degree minus 180 degree plus 70 degree, which will result in minus 40 degree. So, we will add 360 degree to it. The equation will be minus 40 degree plus 360 degree. It will result in 320 degree. So, included angle will be 320 degree answer. Lastly, the included angle D can be calculated as forebearing of DA minus back bearing of CD. Since forebearing of DA is 280 degree and we can calculate back bearing of CD as forebearing of CD is given as 210 degree. So, since it is greater than 180 degree, we will subtract 180 degree to it and find the back bearing of CD. So, final equation will be 280 degree minus 210 degree minus 180 degree, which will result in 250 degree. So, answer, the included angle will be 250 degree. Now, what we have calculated can be easily be checked. The theoretical sum of the included angles, that is 2n plus 4 into 90 degree, it is equal to 1080 degree and n is equal to number of sides. In our case, it is 4. And also what we have calculated, we will sum it. So, sum of calculated included angles, that is angle A, angle B, angle C plus angle D, that is 300 degree plus 210 degree plus 320 degree plus 250 degree, which will result in 1080 degree. Hence, both the answers are correct. So, hence these are checked. Now, we have to make a note in this question that in the process of computation, if the included angle is negative, then 360 degree is added to it, as has been done in case of angle A, angle B and angle C. Now, we will move to the next example. Following are the bearings have been given in a closed compass traverse. Line have been given as AB, BC, CD, DE and EA, and lines forebearing and back bearings are given as you can see it. We have to compute the interior angles and correct them for observational errors. Referring to this figure, firstly we will convert the quadrantial bearing given in this question to the whole circle bearing. As I have discussed this earlier, you can easily convert the quadrantial bearing into the whole circle bearing. It is shown here. Lines have been given, line AB, BC, CD, DE and EA, and its forebearing and back bearing has been converted from quadrantial to whole circle bearing. Now, as the traversing is done in the clockwise direction, so the included angle will be exterior angles. Included angle is given as forebearing of next line minus back bearing of previous line. So, included angle A can be calculated as forebearing of AB minus back bearing of EA. See, we have already calculated forebearing, back bearing of each and every line. So, forebearing of AB is 142 degree 30 minutes and back bearing of EA is 239 degree. So, equation will be 142 degree 30 minute minus 239 degree, which will result in minus 96 degree 30 minutes. So, since it is negative, we will add 360 degree to it and it will result in 263 degree 30 minutes. Now, included angle B can be calculated as forebearing of BC minus back bearing of AB. Since forebearing of BC is given as, or we have calculated as 223 degree 15 minute minus 322 degree 30 minutes, it will result in minus 99 degree 15 minute. Since it is also negative, so we will add 360 degree to it and it will ultimately result in 260 degree 45 minutes. So, answer will be, that is included angle B will be 260 degree 45 minutes. Now, the included angle C can be calculated as forebearing of CD minus back bearing of BC. Forebearing of CD we have calculated as 287 degree and back bearing of BC we have calculated as 44 degree 15 minutes. So, equation will be 287 degree minus 44 degree 15 minutes. So, answer will be 242 degree 45 minutes. Now, next the angle D. Angle D can be calculated as forebearing of D minus back bearing of CD. Forebearing of D is given as or calculated as 12 degree 45 minutes and back bearing of CD is calculated as 107 degree 45 minutes. So, equation will be 12 degree 45 minute minus 107 degree 45 minutes. Answer will be minus 95 degree. Since it is also negative, we will add 360 degree to it and final answer will be 265 degree. So, included angle will be, the included angle D will be 265 degrees. Lastly, the included angle E is given as forebearing of EA minus back bearing of DE. Forebearing of EA we have calculated 60 degree and back bearing of D we have calculated as minus 193 degree 15 minutes. So, equation will be 60 degree minus 193 degree 15 minutes, which will result in minus 133 degree 15 minutes. So, it is also negative, we will add 360 degree to it and it will result in 226 degree 45 minutes. We can also check it. Firstly, we will do the sum of all the angles what we have calculated, angle A, angle B, angle C, angle D and angle E. So, it will result in 1258 degree 45 minutes and the theoretical sum is given as 2n plus 4 into 90, n is equal to 5 in our case. So, equation will be 2 into 5 plus 4 into 90 degree, which will result in 1260 degree. So, as you can see, there is no match from some of the angles what we have calculated and theoretical sum. So, there is some error. So, we can calculate error as 1260 degree minus 1258 degree 45 minutes, which will result in 1 degree 15 minutes, or we can take it as 75 minutes. So, correction for each angle can be calculated as 75 minutes divided by, we have 5 angles total. So, 75 divided by 5, which will give you 15 minutes. Hence, the corrected included angles can be easily be calculated by adding 15 minutes to each angles. So, angle A will be 263 degree 30 minutes plus 15 minutes, which will result in 263 degree 45 minutes. Angle B will be 260 degree 45 minutes plus 15 minutes. It will result in 261 degree. Angle C will be 242 degree 45 minutes plus 15 minutes, which will result in 243 degree. Angle D will be 265 degree plus 15 minutes, which will result in 265 degree 15 minutes, and angle E will be 226 degree 45 minutes plus 15 minutes, which will result in 227 degree. And now we can check by summing all the corrected included angles and it will result in 1260 degree. So, your answer and corrected included angles are correct. Now, we will take another example in which the angles have been provided in the clockwise direction in an open traverse. So, we have been given the included angles, angle ABC, angle BCD, angle CDE angle DEF, angle EFG. And we have also been given the magnetic bearing of line AB as 241 degree 30 minutes, and we have to calculate the bearing of the line FG. So, referring to this figure, we know for a clockwise traverse, forebearing of a line is given as forebearing of previous line plus the clockwise included angle. We can easily calculate from this formula as we have discussed earlier thoroughly. So, forebearing of AB is given as 241 degree 30 minutes, and we have to calculate forebearing of BC. Forebearing of BC will be equal to forebearing of AB plus the included angle ABC. So, forebearing of AB is given as 241 degree 30 minutes, and the angle ABC is given as 124 degree 15 minutes. Adding both will result in 365 degree 45 minutes. Since this value is greater than 180 degree, so we will subtract 180 degree from it. So, will result in 365 degree 45 minutes minus 180 degree, which will give you answer 185 degree 45 minutes. So, forebearing of BC will be 185 degree 45 minutes. Now, forebearing of CD will be equal to forebearing of BC plus the angle BCD. For forebearing of BC we calculated above as 185 degree 45 minutes, and BCD have been given as 156 degree 30 minutes. Adding both we will get 342 degree 15 minutes. Since it is greater than 180 degree, we will subtract 180 degree from it, which will result in 162 degree 15 minutes. Now, the forebearing of DE can be calculated as forebearing of CE plus the angle CDE. Forebearing of CE have been given as or provided as 162 degree 15 minutes, and the angle CDE have been given as 102 degree. Adding both we will get 264 degree 15 minutes. Since it is also greater than 180 degree, we will subtract 180 degree from it, and will result in 84 degree 15 minutes. So, forebearing of DE will be 84 degree 15 minutes. Forebearing of EF will be forebearing of DE plus the angle DEF. Forebearing of DE is given as 84 degree 15 minutes, and the angle DEF is have been given as 95 degree 15 minutes. Adding both we will get 179 degree 30 minutes. Since we know it is less than 180 degree, so we have to add 180 degree to it to find the final answer, which will result in 359 degree 30 minutes. So, the forebearing of EF is given as 359 degree 30 minutes. Lastly, the forebearing of FG is equal to forebearing of EF plus the angle EFG. Forebearing of EF is 359 degree 30 minutes, and angle EFG have been given as 215 degree 45 minutes. Adding both we will get 575 degree and 15 minutes. Since we know it is more than 540 degree, so we will subtract 540 degree from it, and which will result in answer 35 degree 15 minutes. So, forebearing of FG what we have to calculate is 35 degree 15 minutes. We will discuss adjustment of surveying compass. Following are the adjustment of surveying compass, that is temporary adjustment and permanent adjustment. The temporary adjustment are required to be made at every setup of the instrument. Temporary adjustment include the following operations, which are centering, leveling, focusing the prism only in case of prismatic compass. These have been discussed earlier in our previous lectures. In this session, we will focus on permanent adjustment. So, what is permanent adjustment? The adjustment which are made only if the fundamental relations between various parts of compass are disturbed due to careless handling or otherwise. These are called permanent adjustment. The following fundamental relationship between different parts of compass are established by making permanent adjustment, which are: firstly, when plate bubbles if provided are at the center of their run, the vertical axis of the compass should be truly vertical. Secondly, when the instrument is perfectly leveled, sight vanes should be vertical. Thirdly, the ends of the needle and the center pivot should lie in the same vertical plane. Next and last, the center of the pivot should coincide with the geometrical center of the graduated ring. So, firstly we will discuss how we can adjust the plate levels. So, what is the objective for adjusting the plate levels? It is to make the vertical axis truly vertical when the plate bubbles are at the center of their run. So, how we can proceed it with it, how we can test it? Firstly, we have to set up the compass with a tripod on a firm ground. Secondly, we have to bring one of the level parallel to a pair of leveling screw. Bring the bubble central by turning both the screws simultaneously either inwards or outwards, as you can see from this figure. Thirdly, rotate the instrument to 90 degree and about its vertical axis till the level tube lies parallel the line joining the third screw and the midpoint of the two first screw center of the bubble with the help of third screw. Next, rotate the instrument through 180 degree. If the bubble remains central, the instrument is in adjustment. If the bubble does not remain central, we can correct half of the error by capstan screw and the remaining half by the leveling screw, and we can repeat the adjustment until the bubble remains central throughout a complete rotation of the compass. Second adjustment is of sight vanes. Objective is to make sight vane and object vane vertical when the compass is level. What is the procedure? Procedure includes, firstly we will level the compass carefully, then we will suspend a plumb bob roughly 25 meters away. Next, we will move the eye from top to the bottom of the eye vane slit. Note whether the hair of object vane remains in coincidence with the vertical plumb bob. In case the sight vane is provided with a simple hole, one should check the line of sight from top to the bottom along the hair of object vane. Next, we will swing the compass through 180 degree and test the sight vane in the same way, sighting through the hole in the object vane. And the adjustment includes, if the hair of the object vane does not remain coincident, either file one side of the bottom of the vane where it rests on the plate or insert a paper packing. Repeat this test and adjustment until error is completely eliminated. Now, we will have to adjust the magnetic needle, and objective is to straighten the magnetic needle. So, firstly we will test for vertical bending, in which we will lower the needle on its pivot and observe if there is any rocking at its upper surface at the ends. An adjustment include, if so, remove the needle and bend it in a vertical plane till no rocking is noted on replacement. Secondly, test for horizontal bending. For in this, firstly we level the compass and read both the ends of the magnetic needle in any position. Secondly, we rotate the compass until the graduation originally opposite the north end of the needle faces the south end. And thirdly, if reading at the north end is now the same as that way originally at the south end, the needle is straight. If not, half the discrepancy is reading represent the deviation from the straightness. How we can adjust it? Adjustment includes, remove the needle and bend the north end horizontally through half the angle in a direction which would carry it from the north end reading on reversing to south end reading. Replace and repeat till adjusted correctly. Now, we will take the adjustment of pivot. Objective is to set the pivot point at the geometrical center of the graduated ring. Its test include, read both the ends of magnetic needle at various portions of the graduated ring. If the reading differ by 180 degree, assuming the needle to be straight, the pivot is central. Adjustment include, if the reading do not differ by 180 degree, we have to proceed as, firstly, if the difference of readings is variable, ascertain the position at which the discrepancy is maximum. Secondly, remove the needle and bend the pivot at right angles to this position of the needle towards the greater segment of the graduated ring formed by the needle. Lastly, repeat the test and adjustment until end readings agree in all positions. Dear learners, we have reached the end of today's session. I hope you find it informative and engaging. Thank you for your attention. See you in the next class. Thank you.